FTC part 1, we're going to start using it. We're going to start seeing kind of how a pattern will emerge. Now the understanding, at least for myself, was not there until I saw FTC part 2. So possibly you might be looking more at patterns rather than full understanding through this, and then catching what you can. It's a game we're going to play, most certainly. So let's just jump into how we can use it. And this is what we kind of came to the conclusion of last time. FTC part 1 was saying that if you take the derivative of an antiderivative, integral. The derivative of an antiderivative, wouldn't that just kind of unravel whatever it did? And then there's this weird ass game that's inside that says if you're with respect to t here, but you have some other variable here and you're taking that derivative on that one variable, you end up just getting whatever f of t is just in terms of x. I know it sounds like a lot, blah, blah, blah. You got to see it in action. I'm just saying words. You go, sure, clearly. Okay. Let's check out a little problem. Looks all super complicated and shit. I mean, look at this function in here. Look at this. Oh man, that must be super rough. How are we going to ever get through? We're not going to do shit with it. We're going to change the t's into x's, and that's going to be the answer. The reason we're going to change those t's into x's, well, I did the proof for you last time. It kind of popped out, and you're like, hey, I don't know what that means. You don't see it yet. It's coming. You'll see it. Maybe. So it's saying that this question wants us to take a derivative on the function. So it's saying, take your freaking integral. Take your integral. Take a derivative on it. So we need to take a derivative. So actually what we're looking for in our problem is f prime, not f, even though our little formula tells us so. So really what we're looking for here is f prime of x, at least in this question. So that's telling us to take a derivative with respect to x on the integral from whatever, some number up to x. That's all it needs to look like. You got to have some number up to x. Oops. 2 t to the 7th. Oh, that's what I missed. dt. And you don't need this step. I don't need you to write in all this steps. You can jump to the end because once you see the pattern, the second one, I'm not going to write this again. What we're going to say is that these x's are just, or those t's are just going to become x's. And we're just going to write our integrand. The integrand is going to be the answer, except not with t's, but with x's. And here's our solution. E to the x squared minus 1.2 x to the 7th. And there's the solution. That's the derivative of f of x. So when you take an antiderivative, or you take a derivative on an antiderivative, you go back to where you started. It's just what variable are you taking derivatives and antiderivatives on? It's a little trick. It's just a game that we're playing. There's a chain rule hidden in here. I should be multiplying by 1 on all of these. I should be really doing this and multiplying by 1 because we're taking a derivative on x. So there's always a chain rule. That's just a precursor. All right, let's go. Let's go to the next one. This one is just for patterns. Let's just write the answer down. G prime of x is equal to, you're going to change your t's to x's because you have a number at the bottom of the integral, you have an x up at the top as your upper bound, and you're dealing with in terms of x. That's in that frickin' form, which just tells you the solution is x squared plus 4 over the square root of x minus 1. It's just the integrand replaced with x instead of t's. Because when you take a derivative on an integral, derivative on an antiderivative, no, it's a derivative on an integral. I think it's a derivative. I always do that stupid thing. You just go back to where you started, and there's a trick inside of there. With changing our variables. And again, wait till FTC part 2. Now this one here. This one here. No biggie. I should pull this up just a bit. This doesn't have the right form. Huh? You got a number up top and the X is down below. That's not the right form. We can't have it like that. That's not okay. We got to flip that thing over. Remember? You just flip it over, change your balance. Same thing. So negative. And now the X can go up top, the one down below. And we got our cosine cubed 2t dt hanging out right there. And this is still f of x. This isn't f prime. Now f prime of x is, we go and we look at our integrand. Our integrand, and we go anywhere I see a t, I'm going to replace it with an x. But don't forget your negative on the outside. So this is negative cosine cubed of 2t. And do not bring the dt along. That's for when you're integrating. You already took care of that. And there is your solution. Now let's start catching some patterns. Let's get into the game. This is a simple one. I'm just going to write down the solution. G prime of x is equal to x cubed plus 4. Oops, I forgot it there. I forgot to multiply by 1. And then there's your solution, times 1. Because derivative on x is 1. We're doing a chain inside there. When you take a derivative with respect to x in there. There's our solution. You don't need the 1. I'm just messing around. Now let's go down to number 5. And it's the same thing. We got the same integrand. Still dt, still 5 on the bottom, still 5 on the bottom. Call it g, but now it's capital G. Everything's the same except we're going to change what's up top. Now we're going to put in 2x. 2 times x. Not just x, but 2x. All right. Well, we don't have a theorem for taking a derivative on a 2x. So what we need to do is a substitution. Now this is something you will become great with, or you will not finish the calculus series. It's called U substitution, and this is just kind of a precursor to it. It's not U substitution, but we're getting there, this idea. So we're going to let some other letter equal 2x. So that way we can take a derivative on it. We just have to take the derivative with respect to u. But if we're going to take a derivative with respect to u, and it's a function of x, we need to take a derivative on both sides. And we find out that the derivative on u with respect to x is equal to 2. I don't know why my writing all of a sudden looks childlike. My surface is awesome. Moving forward. 5 up 2, and now we're not going to call it 2x, but we'll call it u. All right, everything stays the same. This is a t, and that's a 4, and that's a dt. It's nothing to do with that. Nothing to do with it. But we now need to go find g prime of x. But g prime of x is trapped inside, or x is trapped inside of another function. X is trapped inside of our function with a u in it. So when we go through, and I'm like, oh my gosh, 5 to write that u back in there. T cubed plus 4. Well, we're okay right now, but I don't see where the x's are. There's only u's. U is a function of x, so what we actually have to do is go through and take a derivative on u. And I know this is getting crazy. I'll get to the end. I'll just show you that. I'll give you a pattern. So we'll be like, it's no big deal. T cubed plus 4. Oops, I should be using this. I'm being sloppy. dt. But now we're going to multiply by the derivative on x. We're going to multiply by that derivative on x. That's your du dx. At the end, it's your chain. I know it's a lot. Hang on. We're going to get through it. So now we can punch all our stuff in, and we find out that we get the square root of something cubed plus 4 times our du, and our du is equal to 2, and that something we're going to pop in is u. we just filled it in. Our du dx was equal to 2. Right? We plug it in, but we're not looking for u, we're looking for x. And what we have here is that u is equal to 2x, so we need to go through and replace that as well. And we find out our solution is 2x all cubed plus 4. And let's take this 2 from here and pop it out front. And there's our solution. But let's play that game one more time. But let's change the 2x into an x squared. So let's call it big F of x. And we'll say it's equal to, and we're going to do this one fast with no bullshit inside of it, okay? I won't explain anything, I'll just show you the pattern. Okay. Here we go. Take a derivative. We have the square root of something cubed plus 4. All you're going to do, you're going to take whatever's here and replace your t with it. And on the outside, you're going to multiply by the derivative of whatever that is. What's the derivative of x squared? It's 2x, right? So we multiply by 2x on the outside. So your answer is, I'm going to pull this back out to the front, 2x times the square root of x to the 6th plus 4. And there's your solution. One more. G of x is equal to, we go from 100 up to x squared. Oh, I'm sorry. Plus x squared plus x, I'm sorry. Of the square root of cosine cubed of 3t dt. And we want to find g prime. G prime of x is equal to the square root of cosine cubed of 3 times, let's plug that shit in, x squared plus x. Times, what's the derivative of x squared plus x? 2x plus 1. Bang, there's your solution. There's the game you're playing with FTC Part 1. Don't spend too much time trying to understand it yet. Come back for FTC Part 2, and maybe you'll have one of those, oh, or not. All right, see you.